question number 3 says that during a certain chemical reaction, the concentration of butyl chloride obeys the rate of reaction of the change in the concentration is equal to the negative K times the actual concentration value. And they give you a K value here. So again, if you take a look at this differential equation, it is based on exponential growth. So we could start with our dy by dt is equal to negative K times y. And because this is an exponential growth one, if you recognize it, you can convert it directly into your exponential growth equation. So we have our starting value times e to the kt. Okay, and then we can substitute our k, and we can put in our initial values for y naught and our end value for y. So that's a possibility. Now, it's not a bad idea to especially for now, to actually differentiate this, or sorry, integrate this. So we're going to separate our variables, and then we're going to integrate both sides, and we end up with log y equals negative kt plus c. This becomes y equals e to the negative kt plus c up here, and then that plus c becomes our y naught value. So y equals e to the c times e to the negative kt. Okay, and we can see that the original y value is same as that, e to the constant. Okay, so that's the first part. We want to generate that equation, and again, you can go directly to the equation if you like, but we can also generate that equation by separation of variables. So I'm going to have my equation here. My concentration value y as a function of time is equal to, and they don't tell us what the starting amount is, but they do tell us the k value is going to be 0.1223, and that will be times by t. So there's my concentration, and the question asks, how long will it take for the reaction to consume 90% of the initial butyl chloride? So if I consume 90%, I'm left with 10%. So I'm going to just say that the y naught, the starting value is 1, the end value is 0.1. That means I've used up 90% of the butyl chloride. Okay, so that's my end concentration. So then this becomes e to the negative 0.1223t, and then I can solve this equation. I can solve this for t. So I get log of 0.1 is equal to negative 0.1223t when I log both sides, and then solving for the t value, the time it takes for this to happen is going to be log of 0.1 over negative 0.1223, and we end up with a value of 18.83, and since the units are in seconds, the time is in seconds.